let's this time take a 5 electron pair case. So 5 electron pair case, and we begin as usual with a case where all of these electron pairs are bonding. So 5 electron pair case, 5 bonding, 0 non-bonding. A typical example in this case, in this 5 electron pair case, where all electron pairs are bonding, is phosphorus pentachloride. So PCl5. And the first step is to draw a possible Lewis structure. And in that regard, we first calculate the total number of valence electrons in this formula. So the valence electrons will be, well, phosphorus is located in group 5A, so basically it's under nitrogen. So there are 5 valence electrons by phosphorus, and there are 5 chlorine atoms, and each of them has 7 valence electrons, because chlorine, just like the halogens, okay, they are located in group 7A, and halogens, because of that, have 7 valence electrons. So 5 times 7, the total will be 40 electrons. So 40 electrons, 40 valence electrons total in this phosphorus pentachloride case. Now the next step is to divide that number by 2, and if we divide 40 by 2, we get 20 electron pairs. So 40 divided by 2, and we get 20 electron pairs. Next step would be to draw a Lewis structure, and with that we draw the central phosphorus atom, and phosphorus makes bonds with 5 chlorine atoms. So that's one of them, that's 2, 3, 4, 5. So we have the central phosphorus atom, we have the 5 chlorine atoms, and now what we should do is we should draw a bond between the central phosphorus atom and each of these chlorine surrounding atoms. So that's one bond, that's 2, that's 3, 4, 5. So there are 5 bonds. Now if you look at this structure so far, phosphorus has 5 bonds, so therefore there are 8 valence electrons, but we had 40. So what we need to do right now is to satisfy the octet on the surrounding atoms. Now each of these chlorine atoms is bonded with phosphorus, so each of them has 2 electrons so far. So what we need to do is we need to draw the remaining 6 electrons. So that's 6 for this chlorine, 6 for that one, and 6 here, and 6 on the 4th, and 6 on the 5th. So each of these surrounding chlorine atoms is now surrounded by 8 electrons, and therefore they all satisfy the octet. So if you add this up, if you add the total number of valence electrons used so far in this Lewis structure, you would find it's actually 8 by 5, so that's 40. So 40 valence electrons used so far, and that's reasonable because we had 40 electrons total to start with. The number of electron pairs is also 5 on the around the central phosphorus atoms, and 3 lone pairs around each of these chlorine atoms. So the total will be 4 times 5 again, and that is 20. What about the arrangement of electron pairs or the orbital shape, and therefore the molecular shape? Well, let's try to make a model of phosphorus pentachloride. So that's a possible Darling model for this molecule. And if you look at the orbital shape or the overall arrangement of electron pairs, you will find out that it's like 2 pyramids stuck to each other. So that's like a pyramid up, and this is like a pyramid down. So it's trigonal pyramidal. So 2 pyramids which take the shape of a triangle. So therefore the orbital shape is trigonal or triangular bipyramidal. So let's write that down. Okay, the arrangement of electron pairs is trigonal bipyramidal. And since there are no lone pairs around the central phosphorus atom in this case, the molecular shape should be the same. So the molecular shape of phosphorus pentachloride is also trigonal bipyramidal. So let's write that down. So to conclude, basically in phosphorus pentachloride, the total number of electron pairs around the central atom is 5, and all 5 electron pairs are bonding. The orbital shape or the overall arrangement of electron pairs is trigonal bipyramidal, whereas the molecular shape is trigonal bipyramidal.